Okay, welcome everybody. Hello, my name's Eric Schabell. This is Ricardo, Rick we call him. He'll be talking in a minute. I'm going to kick this thing off. We're looking today at exploring open source DevOps at scale. So what does that mean? This is going to be an architectural talk. So we're looking at designing very complex things, using multiple products, solving big problems, clouds, things like that. So when we think about architecture, whether it's a house, a bridge, software, infrastructure, whatever we're doing, we have great diagrams, right? We get these pictures delivered to us. We get architects in our companies that are putting these things together. They're very precise about how big something's supposed to be, how much it's supposed to weigh, where you got to put it, all these kind of things, right? And then you go out and build these things and you look at them and it's a matter of perception. And I know this is a really radical thing, right? We're not this stupid, are we? Somebody was, but we're not. But it's happened in all our software lives. You've designed something, you give it to your team and they come back with something, you're like, how did you even come up with this, right? How does an architecture in a company end up at the dead end where it ends up? It's just an amazing array of decisions that have happened based on your perception, right? Wouldn't it be great if we could step back and take a bunch of previously done designs and have those all lined up so we can kind of explore those and have something realistic and real to look at when we're dealing with our architecture. So instead of coming with just a bland, very mathematical kind of document of how we're supposed to do something, what if you're looking at these kind of things? You're probably going to end up with a little bit better story, right? How many people here have customers or sales or things you're trying to do and they want to see what another customer did? You know why? Because they don't want to see what you're saying on paper. They want to see what someone's actually did in the real world. Everybody here has probably used a product or a software thing at one point in time, and they promise all kinds of things, but realistically about 50, 60, 70, 80% of the stuff actually does what it's supposed to do, and there's certain areas of the product that are a little bit rough you might not want to try, or it doesn't scale, or what you're thinking or told it was going to work doesn't. Fair enough. What we decided to do was step back and Red Hat right now and take a good look at what marketing was doing. Taking the promises and to be really short on how you talk about it, taking fact versus fiction, right? So marketing will promise you all kinds of stuff. Who doesn't watch advertisements about how great stuff is? You order it. Remember those guys that sell shit at midnight and you come back from drinking and you buy it and you're really not impressed with what shows up the next day, right? It's not that bad, but you get the idea. I'm trying to give you a feel here. So we stepped back and we said, hey, what if we looked at 2 to 3 customers, researched it for a certain use case, and then put together an architecture? Now there's a problem here. It's not a public reference, so I can't look at your stuff, replicate it, and share it with you, right? So let's get rid of that problem by just saying, let's abstract that up. So I take 3 things that went successful and come out with an abstract storyline, and then how do I represent that? So what we did is we took the customer research and we developed a way to diagram this in a non-official diagramming language. I'm looking for something that you can talk to with normal people. You can go to your CIOs, you can go to your architects, you can go to your developers, they all get it. You should be able to talk to your granny with these things. It should be quite easy, right? We do a logical level view. We do a schematic level, which is like a flow through whatever you're looking at in the use case. And then you have detailed levels if you want to zoom into some element inside a diagram. Really straightforward. Then later we added what you see there is that red one on the left side, a marketecture. So even higher level, so when you're talking to someone really simple about something, you can just do really high level blocks and give you a real short overview of what's going on in a couple of minutes, right? We did some presentations around this stuff so you can talk to it from front to back in about 10 minutes, something like that. Very straightforward. The idea being you're talking about a use case. Imagine something like omni-channel integration, something like cloud adoption. And then what's that look like? Not a high-level story, but what customers actually did to do this stuff, right? And so you can kind of walk through the storyline. And we do a video around how to talk to it. It might be a solution brief if you want to leave something behind. And if possible, there might be demos behind it, different pieces usually, because you're talking about really complex stories. What does cloud-native development look like? We develop into the cloud. That could be a lot of different things. So the demos get really complex. Even created demos that are just slide demos, but it's the ability to see things moving around that you don't see on a screen. Anybody here has built a container and seen it actually move around on your computer? Don't think so. Look, it's in a registry. Yeah, I can show you an entry in a registry, but that could be a screenshot. You know, it really doesn't matter. But watching like a box flow around into a registry and things like that, it's a conversational piece. Whoops, too many. Back. Now I don't even know where I'm at. This is a very weird clicker. There we go. Yeah. Sorry. There you see the 3 levels. Logical level on the left, schematic in the middle, and the detailed on the right. Realistically, a logical is about grouping the elements. I'm not talking about components. This isn't a TOGAF and any kind of stuff like that. It's really straightforward with a couple of colors for like some of the stuff is application stuff, some of it is services, some of it is in the infrastructure layer. Some of it's on-premise, some of it might be in the cloud. It's kind of a grouping of where those components can be found in an organization. It's not saying you got to do that. This is how successful people do it at scale. And that's really the key right there, the scale. So we're not talking about like 1 or 2 things being done. We're talking about like thousands to hundreds of thousands of transactions, things like that. And that's really, really interesting to people, it turns out, right? And then when you get to the schematic one in the middle, sometimes we even include like a numbered flow through it, how it happens. So in the case of the story with cloud native development, when you're watching a container move through an organization from dev to test to production and the different registries and things like that, that's kind of fun to see where that's actually physically going in your organization and in your clouds if you have multi-clouds, things like that. And then the detailed ones is because we had some guys in the field say, hey, I'm talking about this great big huge story. We're moving through it, but then in that conversation, the C-level guy gets excited about, we have a problem in this corner. So now he wants to zoom in and start talking about that. So then you can pop open a slide. It's one component, one element. You're digging down into that, and you can discuss what that's talking to, what it's connected to, who he's talking to, and what he's getting done. And with that, I will pass this off to Rick, and he will share what one of these things looks like. We're going to walk through this one.
Thank you, Eric.
I'll be back later.
Cool. So yeah, Eric talked, he said that the first or highest level diagram that we have is architecture. What we did here was for customers that use SCADA and they use edge devices, and they need to renew the integration with their applications. We created this architecture. So the business drivers here were, first of all, the enablement of the SCADA functions for the business. So if they need, for example, demand forecasting or consumption analytics or things like that, so that they can access the SCADA, all the RTUs, so the remote terminal units and all that, and get the data from there to exploit them. Then they needed to be NERC compliance because in this particular case it was for energy providers. So the NERC is the North American Energy Regulation Compliancy, I think. So they needed to keep compliant to that in terms of segregating the networks and all that. And then they needed to modernize the way they develop applications for SCADA and for this interaction. So we can see here that we used there's 2 different zones. Okay, so the electric zone where all the edge devices, the SCADA devices are, and there's a cluster there with all the applications that are going to interface with them. And there's another zone, which is the enterprise zone. They're completely segregated, and that's where the applications, the business applications will run, and the applications that will get the data from the SCADA finally. There's another layer, which is the management layer for the clusters. So it's the cluster, the RACAM, for example, so the cluster administration and cluster security as well. So this is the highest level, as we said. Then we move on to the logical design. Here we need to split it into 2 because it's quite complex, but so that you can see the different parts of it. So we have part 1 is for the electric zone that we have seen, part 2 is for the enterprise zone, and then part 3 is for the control plane for the management. So if we zoom into the electric zone, we can see that the components are the SCADA, all the applications and devices that can be there, for example, edge devices, as we said, RTUs, so remote terminal units, all the supervisors, the monitoring applications, the dashboards. Then we have the actual container platform that they have spun up with all the applications that will connect to the SCADA devices. So we can see a SCADA interface, for example, with applications to capture service interruption, to capture service provisioning, data acquisition, network information that will be consumed in the business zone. And then we have all the cluster components, so applications, CI/CD pipelines. So we have service mesh, cluster dashboard, an ingress controller, And we also have other applications or other solutions that are running on top of the container platform. So the API management that we will see in more detail, because in the logical diagram we don't mention the applications or the implementations per se, it's just a general representation. And we have a messaging services, so to ensure the secure connectivity between both zones and to have a message queue to exchange information. And if we go to the enterprise internal zone, we have basically the same. So another Kubernetes cluster with the same applications on top of it. But then we have the business applications, so the ones that will connect to the applications in the other zone. We have replicated the API management. We have the messaging service as well, so that both clusters can talk. And we also have audit and logs and single sign-on, so that the business applications can log on to the and connect to the queue, the messaging queue. Here is the control plane management. So we have cluster management with cluster lifecycle, application lifecycle, governance and risk. We have cluster security, security policy enforcement. And we also have added an automation on top of it that will be implemented with Ansible. We will see that later on. And it's the automation orchestration. Also in this zone is the some analytics and prediction applications that will consume the data that comes from the SCADA. And here is the more detail that we were talking. We zoom in and we go more detail. Here we can see both zones with both OpenShift clusters, and we'll zoom in and go to the zone 1 as well and see what we have seen in the logical diagram, but with the actual implementation. So here we see that it's an OpenShift cluster. We have used OpenShift, and we can see that for the message broker, we have implemented AMQ, as well as for the secure message queue and for the secure connectivity. The API management that we're using is 3-scale. That's what we'll talk to the network information application that goes to SCADA, get the information from the network device, and then we'll pass on this information to its homologous or its peer in the business or in the enterprise internal zone. We can see it's basically the same structure, but the only thing that changes are the business applications that are there. And and then I hand it over to Eric again.
Yep.
Thank you.
Okay, so who's excited about the SCADA stuff? Yeah, that's kind of specific to what you're doing, right? So that may not apply to everybody. Now I got one for you that's really straightforward. I think everybody can apply to. Who here's ever had a lung x-ray? Scan or whatever they call that here, right? Who's ever had a pneumonia here? Well, this one's for you, right? This is the same idea, edge medical diagnosis. It has a little bit of everything in it. We're talking about some edge devices and activity on the edge. We're talking about AI/ML stuff is incorporated into this. We're talking about integration. We're talking about having something at a medical diagnostic center, and we're having stuff out at the locations where they're actually having patients come through and be x-rayed, monitored, checked at emergency rooms or wherever it happens to be. Most of this was focused on what was happening in the US. That's where this was actually applied at several locations, but it is not limited to that. It's just the stuff that I happen to research around it. So you can see here you have the medical facility, you have a central laboratory, and you have something in between there, right, which could be in the cloud doing some of the work for you. It doesn't have to be, but it can be. And you kind of get an idea now to set this up at scale where things need to be located. You notice I'm not saying what you have to connect, what ports, what things you have to use. Most of the time we're pushing something with open technology, right? We're Red Hat. It's open source. It may be mine, it may be somebody else's, but it's open, right? We don't have everything. We don't try to be everything, not yet anyway. So you see here at the medical facility, you have the imaging that you're taking. There's of course some stuff going on with this stuff to anonymize it. You can't be sending data all over the place when it's medical information, right? I don't know how private or how you can identify my lungs versus your lungs, but you know, whatever. That's kind of important to be careful with that. You have some models that are being done, and what you don't really see at this level is the developer part of that. So we have data engineers doing stuff. We have developers developing apps. You have an AI/ML model. How do you deploy these models? That kind of stuff is all not really shown here. This is just where to find the deployed stuff, right? And then you have the central laboratory, which is basically where the core development is being done, where you're retraining the models, where you're improving on what you're doing using the anonymized data. See how that works in like 2-3 minutes on a really high level slide, right? This is some fluffy stuff you're looking at. Not no more. Now we get down into the same idea what you just looked at, but now we're looking at some logical stuff. Where are the elements and the stuff we're doing being grouped, right? So again, you see the diagnostic facility. We have some blue stuff, meaning it's external to everything we're doing. It's out there, it's not my stuff. And then you have the green stuff, which is showing, does it look green to you guys? Yeah, okay, green, blue, and brown is what you roughly should be seeing. So the green stuff are apps, application layers, that kind of stuff. The blue stuff would be anything around the middleware that you'd be using, so stuff that's supporting at scale, like APIs and that kind of stuff. And all the brown stuff would be the really core infrastructure stuff. Not so super exciting to look at this level, but this gets more interesting. Anybody that develops software as an architect, we love these kind of things, right? You still see, well, it's a little bit hard to see up here, but these slides are going to be available. All this stuff is available in the GitLab repository, so you can look at these things. We're very open on as much as we can. The only thing you don't get is the customer research. You have to join Red Hat if you want to see that stuff. So that's the only part we hide, to be honest. Inside these slides, in the speaker notes, not in the PDF, unfortunately, but if you go to the GitLab repository, you can click on it and you can open them up in the tooling. The tooling behind this that we use is self-hosted in a browser. It's free for you guys to use, and it will automatically open what you're looking at right here. You can start dragging this stuff around, you can rename it, you can put other stuff in it, you can change it all. That's just a side note to what we do. But what you see here, if you go all the way on the left side, is somebody out there getting his x-rays done, and they're coming in through the x-ray machine. That's the edge part there at the bottom on the left. And they're going to be evaluated and pumped through and anonymized, and then they're going to be applied to the model. And the whole idea here was pneumonia. They were trying to, in one case, trying to identify pneumonia in lungs just based on images, anonymized images, not history and data and medical behind it, just the images. And they found that they could get about 80% correct without anybody intervening. That means you're freeing up all your medical staff to do more important stuff. Like look at the 20% that might be something else. Maybe it's a cancer lump. It's got nothing to do with pneumonia or nothing at all. I don't know, black lung ear minor, whatever it happens to be. So the whole idea behind that was to anonymize that kind of stuff, get it back into the actual facility in the data center on the right side. And there you now all of a sudden see a little bit of the developers and stuff way on the right outside the box there, the little person. And that's the person that's making the data engineering, the models, and deploying that stuff out and updating and constantly crafting better stuff to identify more. 80% is not enough. We want 85, we want 90, that kind of stuff. We have another way to look at this, and this is when you look at the developer side of it. So this is a second view on the same storyline, and definitely applies to this conference. This is very much a GitOps, DevOps kind of storyline. Here you see on the one side that the developers at the bottom are pushing code through repositories, adjusting the apps, the interfaces, the notifications, the services, that kind of stuff, and it's deploying out into those green boxes out at some facility, right? That's just the way it works. They're using pipelines and all that kind of GitOps stuff. Anything that gets synced in the repository then syncs to your cloud platform. When we look at Kubernetes, the idea behind Kubernetes is that we tell it with configuration files, manifests, and all this kind of stuff, how we want our platform to look like. And it's got to sync up, right? Two people are doing this, the developers with their code and their applications, and the dev guys on the other side with, what is it supposed to be configured like, what's supposed to scale, what isn't, where's it supposed to go. So that's what you see at the top there. That's the ops guys and gals. You'll notice that we don't have guys or gals. We have like a unisex thing here. So I did one of these one time with hair hanging off, but it's not appropriate, I think, to single out any one sex in those things. So we're trying to do it as unisex as we could. You see there that they're also going into a code management system. They're syncing up their manifests and their configuration files, and everything is getting pushed out into the platform to adjust as necessary at a facility. And here you see a little bit of a numbered thing that walks through step by step. You can follow each one with some words and stuff. It's a little bit small on the scale here, so I don't think we're going to spend too much time with that. If you're interested in more stuff here, we have a website. It's a public one at the top there. That will get you in contact with all the public stuff per use case. And there's about 10 we've gone live with. When you get into the back end, we have a total of 24 right now that are published and about 5 that are in process. You'll see them in the GitLab, all of them as they develop. We just constantly keep them live in there. That's in the architectural examples link right there. And the tooling you can go straight to and make fresh stuff. You can also, from the examples repository, jump straight into a load me icon for the project you're looking at or the diagrams you're looking at, and you can get I would almost never start with the new one. I have a workshop behind it too that walks you through how to do it from scratch. But I always grab the old stuff and then work off it. It saves you a lot of time, right? You can just rename stuff and move it around. So the workshop's also on there about the tooling, teaches you how to do the logical, the schematics, and the detailed diagrams. With that, is there any questions? We have to go kind of quick because we only get a half hour. So, any questions? And again, you'll notice most of this is not, we're not trying to enforce a TOGAF or anything complicated like that. We want to lower the bar so that people can make diagrams they can talk about. All right, that's kind of and I'm not cutting on TOGAF or any of those things. It's just really hard to have a conversation with the head of ops about, what he's looking at when it's an extremely complex diagram with all these notations and things that need to be in there to make it. And it's fine when you're with an engineer talking about some kind of workflow diagram or a sequence diagram. They understand that language, but that doesn't translate across the organization. It's really hard to do. So by backpedaling and say, okay, let's just do a subset, let's keep it simple, let's have colors for certain areas, certain icons, and that's it. The rest of it is about the story we tell. So I hope you enjoyed the story we told, and have fun this week.
Thank you.